So when we put together these agenda for this meeting, I just never have the heart to put my presentation in front of anybody else's. So mine's going to be last. And initially I was going to talk about polar to grid and geo to grid, but those packages for CSPP have been talked about by both Liam and Graham. So I decided that it might be worthwhile to talk about the global users and the contact that we have with them. So I'm calling this the hidden users of CSPP. So we've seen this slide before. Alan showed it when he gave his presentation. So this is the geographic distribution of the CSPP LEO registrants that have downloaded at least one set of the software suites that's available in CSPP LEO. So there's almost 3,000 users, 170 countries, and all 7 continents. Now, we've seen a few of the distributions of where the antenna locations are actually located around the world, and there's no way that each of these sites has an antenna. So there's a lot of users out there that we don't know about. So what we're trying to do is to find out some information about the users. So we have very little direct contact. Well, we have direct contact with a very few of these users. So we're wondering who they are, what portions of CSPP are they using, and what applications are they supporting. So to help us answer these questions, I just decided to do a simple Google Scholar search on the words community satellite processing package, and I limited the search to those since 2019. So here's some of the results that I found. So there was a publication in 2020 that was published by a group in Taiwan, Journal of Geophysical Research, Atmospheres, and what they were doing was comparing the CSPP GeoCat retrievals from the AHI instrument, so the Himawari 8 instrument, and they were doing that by comparing them to MODIS, to the CloudSat radar, and to the Calypso LiDAR, as well as radiosondes. And what they found in their publication was the cloud properties, the cloud optical thickness, cloud effective radius, and the cloud top altitude were consistent with what the retrievals they found with MODIS. So this is an actual screen capture of one of the figures in that publication. So the top part are the AHI retrievals from CSPP GeoCat compared with the coincident MODIS retrievals from that time. So another CSPP Geo publication that was out there, or data set, was this research quality data set that they created from CSPP GeoCat, both the level 1 radiances as well as the level 2 GeoCat products. And this is on a public domain site for their researchers over the Australian domain. So it's a product of the Center of Excellence for Climate Extremes Extreme Rainfall Research Project. So there was also this internal publication to KMA. So this is in Korea from 2020, their Ocean Research Operations and Support Department, Korean Ocean Satellite Center. So they published analysis of the location changes of fishing activities of ships using VIIRS DNB data. And if you go to that reference, what you see is that they're studying the distribution of night fishing areas based upon the VIIRS day-night band, which can detect then the lights from those ships. And they also used NOAA SST data to do this, and their results were that the data used in the study confirmed that the distribution of light, so where the fishing boats are, varies according to sea level changes. So then there was this publication that was published in Remote Sensing in 2021, and this was done by some researchers in the US and Spain, so from the Department of Biological Sciences in South Carolina, as well as the Coastal Ecology Group from Spain. So they used CSPP ASCO sea surface temperatures from NOAA 20 VIIRS to validate the EcoStress SSTs that were retrieved. So that's the instrument on board the space station. And this is a screen capture from that publication. At the top, you're seeing the NOAA 20 VIIRS SSTs that were retrieved from this data set in 2019. And the bottom panel shows the same SSTs with the insert of the EcoStress higher spatial resolution instrument. So there was this publication from this conference, Earth and Environmental Science, that was done in the Czech Republic in 2021, a brief survey on the availability of satellite air pollution data. And under the heading of this publication, 2.8, NOAA 20, they mentioned the community satellite processing package there. So there was this publication, which I could never translate correctly, from Belarus in 2021, updating the Earth remote sensing software for the detection of thermal anomalies. And in this publication, they're talking about running the fire retrieval algorithms from NOAA satellites, and they even have the screen capture of how they use CSPP software to be able to do fire detections, and this is their visualization interface where they click on one of these fire retrievals and get the fire temperature from Belarus. So here's a publication, Frontiers of Earth Science, and actually 2021, not 2022. So this is from Korea, estimation of marine winds in and around typhoons using multi-platform satellite observations application to Typhoon Sulik from 2018. And they use the CSPP GASP, which is the AMSR2 software package, to study these typhoons using the wind retrievals over the oceans that are done with that package. And if you look at this figure, which is again from that publication, the bottom right panel, these are the AMSR2 retrieved ocean winds. So we have worked with groups in Indonesia before, but we had no idea what they were doing with some of the software. So from Indonesia in 2020 was this publication from Earth and Environmental Science. So current development of community satellite processing package to support direct broadcast remote sensing satellite data processing. So what they did in this publication was actually to create a main block diagram of all the current available CSPP packages and how they would advise that you set up your system. So they start with the different satellites. The red are the different packages of CSPP, all the way down to the visualization portion where they mention Polar to Grid and the Sounder Quick Look software as well as Hydra. So another, I extended the search to 2017 because Satya asked if anybody was using CSPP new caps out there. So here's a publication that was done in 2017 from Indonesia as well. And this one is in Proceeding SNSA. I'm not too sure where that publication was published. But this was done to study greenhouse gases using new caps. And they even have in this publication an interface for their retrievals. So over their domain, so this is a Google Earth interface that they created. And here's the CSPP new caps retrievals that they're producing and the different trace gases that you can choose. So in this case, they're showing that if you click on one of these points, you'll get the ozone retrieval from that particular, so it's total column ozone value at that particular location. So we have worked with this gentleman, Tio Lacava. He couldn't make it to the meeting this year, but he has been at previous CSPP Users Group conferences, and we didn't know that he published this. The National Research Council is where he works at in Italy. So they developed a flood algorithm on the potential of RST flood on VIIRS data for flooded areas detection, and that was published in Remote Sensing in 2019. And so what he's doing with the CSPP software is using it as a validation and comparing it with the algorithm that they developed. So again, on the right is a screen capture of the figure that's in this publication, and what he's showing in the red is the algorithm that they developed, and what he's showing in the yellow is, so the red is the algorithm that they developed where it's showing flooding where the CSPP version is not. Where you see the yellow, that's where the CSPP flood algorithm is showing flooding where their detection is not, and the green is where they agree from several different cases over southeast Italy. So this search, Google Scholar search, was also where we ran into CSPP being mentioned from the Quad Leader Summit, and this is something that Mitch already mentioned earlier in the meeting. So they mentioned CSPP as part of the cooperative that they're doing between these 4 countries, and again, it was mentioned, this is available at the White House website. And under the heading of space, they're talking about how they're cooperating to collective expertise to exchange things like, for example, satellite data, and one of the programs they mention is CSPP. So just in conclusion, we know there's a large global CSPP user community, and most of whom we don't know about. We can identify sometimes the location that the country they're downloading to. Sometimes if they're willing to, they put their organization in there, but how they're using the data, we're not always sure. So the results of this simple study indicate that the software is being used globally for a variety of applications. And I think that they prove the value and integrity of the products that are created by the software. And that's a credit to all those who go into this entire project. So we'd like to thank all of you. And that's really the end of my talk, but I also wanted to say one thing about Polar to Grid, because I know there's a lot of people out there who use this package. So this is the reprojection package, making it easy to create high-quality images from CSPP satellite products. So we're working on a significant update that's going to hopefully come out soon. It's Polar to Grid version 2.0. So there's a 3.0. Sorry, 3.0. Let me change that.
Oh, sorry.
Sorry, Jess gave me the big X. So even the implementation of how the scripts are executed is going to change. So there's going to be the -R reader -W writer, which is very similar to how Geo2Grid is implemented. So there's a reason for this. We're not doing this for nothing. This is going to improve things like it's going to be much more efficient and much more memory intensive. It's going to allow features in SatPy library to be much more easily incorporated in a Polar to Grid, and it's going to make future updates much easier. So I know that this change that's coming may be a bit painful, but we're hoping that it'll be worthwhile. And Jen in Alaska, we know how much you use this Polar to Grid. J-Cable sent us a whole list of how you execute it, so we're going to include that in our test suite. So, okay. So the target release date, at least for a beta version, we're really hoping to get out August 2022. Oh, thank you.
Thank you, Kathy. Do we have questions for Kathy? Yes. Jen?
Oh, it's easy. How do you get access to, or how do you get on the list for betas?
Just let me know. I'll be happy to. Anyone else too, yes. We would love to have testers.